Hello, I'm Susan Hammond and I'm one of the chemistry teachers at Woking College. We're going to have a quick look at what it's like to do A-level chemistry. Now, I'm going to spend most of this sharing a PowerPoint with you, so there'll be a little bit of time where we're just doing transitions between looking at the PowerPoint. So I just need to get to that first to do a screen share. So I will go to one of the other tabs and that will take me to our Taste Today PowerPoint. And then let's just make this larger. Just takes a moment. Right, that's better. So what we're going to look at today are van der Waals or London forces. There are two different names because AQA use van der Waals forces, but that strictly speaking, that encompasses rather more than we're looking at today. Some of the other exam boards use the word London forces, which is a bit more exact for the type of force we're looking at. But I will stick with van der Waals because we teach AQA and that's what they use. Now, the reason that we have chosen van der Waals forces, London forces, to look at is that like quite a few of the topics, this occurs in GCSE. You'll be introduced to it. You do it in A-level. There's not a great deal of change between GCSE and A-level for this particular subject. Some of the things we look at, there is a big change between GCSE and A-level, even though we're looking broadly at the same topic. And then also, van der Waals forces, these forces between molecules, carry on to university. And sometimes you can be looking at much more complicated things, obviously, once you get to university. Right, so van der Waals forces. We're looking at physical rather than chemical bonds. Now, throughout this PowerPoint, I have just put a few little questions for you to think about. So first of all, I'll just give you a moment. Could you come up with the difference, what you think the difference between physical and chemical bonds are? So that's just clicked in straight away. And as it says here, some of these questions are not quite as easy as you might think. We look at chemical bonds a lot in A-level chemistry. And again, you should be introduced to this in GCSE, where it's all about electrons, either sharing or moving them from one atom to another, in which case they become ions. So movement of electrons, and crucially, they are also very strong bonds. Physical bonds, or we sometimes call them forces, they can be very strong, but frequently they are not nearly as strong. And these come particularly from electrical charge. In A-level, we're looking at electrical charge. Now, we are not doing this. Oops, let's just go back. So don't worry about this. But just to show how I'm doing quite straightforward things, at the end of A-level, and this would only be a few students if you were applying to Oxford or Cambridge, you could be looking at something like this graph, rather complicated equation. And I would use this sort of thing as rather a tricky question, practicing for Oxford or Cambridge interviews. So the same subject can get a lot harder. So back to the GCSE. What we're going to do is look at van der Waals forces as physical forces, and also crucially, they are attractive forces. Chemistry is very, very precise. So it's no good just saying it's a force. You have to specify whether you're attracting something or repelling something. So we've said it's about electrons, and you'll have come across electrons, but what actually is an electron? So just have a moment. How would you define an electron? So this is what Wikipedia says. And I have deliberately chosen something that goes beyond GCSE, goes beyond A-level, to show you that we get this progression. So what we're looking at GCSE and also A-level is just that it has got a -1 charge. Leptons, that's to do with physics. And if we are properly going to define an electron, we're looking at quantum mechanics. And there we're moving into physics and we're looking at university information. So we do a simple definition, -1 charge, a fundamental particle, but it gets a lot more complicated than that. Go on to the next one. So we've got the electrons. We know that those are particles that have a -1 charge. So another question, what's going to happen if two electrons get close to each other? I've said in different atoms because that's what we're looking at, but in general, if two electrons get close to another, what happens? So hopefully you have said, if we get two things, both with the same charge, both with a negative charge in this case, they're going to repel. So I've underlined that here. But we can go on. We can say, and again, this is beyond A level. It's not harder, but we just don't look at it particularly. An electron is going to generate an electric field. But if we do go way beyond A level, how do you explain it? We're back to quantum electrodynamics. So if you are interested in chemistry, and this is relating to physics as well, then you can really take this much, much further and explain it a lot more. So the little graphic here is showing what happens with van der Waals forces. These are two neon atoms, and the blue dots within the atoms are showing electrons. Now, don't worry about the actual number. Quite frequently, we're concerned with the outer electrons, and we've just got, I'm trying to count, I think 10 electrons, just showing all the electrons for neon. But it's really the outer ones. And if you can see where it freezes, at one point on the top atom, we've got rather more electrons, and that has a slightly negative charge where the two atoms meet. And on the bottom neon, the electrons have moved slightly to the other side, and that has a slight positive charge. So we have this instantaneous charges. These are moving about the whole time. We've got a little bit positive and a little bit negative, and these attract. So we can have another look at that on the next slide. So if you just read through this, this is the explanation of van der Waals forces, and this is something that could come up in an A-level question. And I think last year or the year before, it was actually in an A-level question or an AS question, and you actually have to explain how van der Waals forces arise. So instantaneous, it means it happens in that exact moment. And so a dipole is when we get a plus and a minus. So di is 2, and the poles are the plus and the minus. If you look at the atom this time, we've got delta plus and delta minus. Delta, a lowercase Greek letter, it's like the letter D, it just means a small amount. So it's a very small plus, a very small minus. So if you could just read through that. And then the second part of this, the induced dipole, that means that it is made to be happened. So we get a dipole on one atom, and that just happens with the electrons whizzing about. And at one moment in time, we could get a little bit negative charge on one side, a little bit positive on the other. Now, if we look at this with a few atoms, this delta minus here, if we've got electrons, more electrons where the mouse is, then or where the cursor is, then that is going to repel the electrons on this middle atom. Then the electrons move to the other side, so we end up with delta plus on the left, delta minus on the right. And these delta minuses and delta plus attract each other. They are very, very, very weak forces, but because there are an enormous number of atoms, or it also happens with molecules in any piece of matter, those weak forces add up to sometimes a medium and even sometimes a strong force if you've got a lot of them. So this is how we explain van der Waals or London forces. One of these has slipped to the side a bit. What this slide is showing, if we look at the noble gases and we go down the noble gases, so the number of electrons in helium, neon, argon and krypton increase, and the boiling points, although they're very low, you can see how the boiling point of krypton is more than 100 degrees. greater than that of helium. So the more electrons we have, the greater the van der Waals forces, and the more these atoms are held together. It's the same with the alkanes. So the bottom one, propane, is just slipped, but those are molecules being held together. And again, if you could just read through this. So they're relatively weak forces compared with chemical bonds. They are the forces that are holding gases and also lots of organic liquids and solids and some other liquids. So bromine is a liquid, and also some solids as well. A lot of A-level is understanding, but you do have to do a certain amount of learning, and you do need to know the sort of characteristic properties of van der Waals forces. And going back to what I said before, we don't even mention this at A-level, but if you carry on with study, particularly if you're looking more at physics, although it does come into chemistry, we need a quantum mechanical explanation to how does this force actually work. Now, this is a slight detour. One example of a solid is iodine. Iodine is in group 7 or 17, depending how you define it, of the periodic table. And we do group 7 at A-level. So just a very quick look. So this is a little YouTube video about iodine. There isn't particular sound on this. So one thing about iodine is the bonds holding the individual molecules are very, very weak. And it is actually a solid at room temperature. But if you heat it up to it's just over around about 115 degrees, then that solid iodine will sublime. It's unusual. It goes straight from a solid to a gas. There isn't a liquid phase. And so, again, for A-level, you need to know that solid iodine is a grey-black or a black solid or a purple vapor. And this video is showing that as you cool it down, so they've just put some iced water in the glass, and then as it cools down, it goes from the purple vapor. It's just going to show you now, and it's going back to a black solid. So we do study iodine, and you need to know some details about it. Right, back to van der Waals forces. So what I've said with this is we're going to go, again, we don't really look at this in A-level, a little bit, not beyond, but alongside A-level, and look at the uses. Now, if you are thinking beyond what you are going to do at A-level, and probably most of you haven't yet, but you will get an idea of when you're doing your A-levels. Obviously, chemistry, physics, I've mentioned. Another popular or growing in popularity course is material science. Material science is in between physics and chemistry, and that often is taking things like van der Waals forces and lots of other things in chemistry and physics, and how can we actually use these? How can we use this information, and how can we make new and useful materials? So material science is tremendously important in the modern world and is coming up with all sorts of things. Now we've got a picture of a gecko. Geckos are a family of small lizards. They are, well, I think they're very cute, and they have got these amazing feet. So if you look at the gecko, they've got these great big toes, and geckos can just run up walls and run across ceilings and hang on without falling off. It doesn't matter if the wall is rough or it could be completely smooth glass. And it was only in about the year 2000 that scientists actually worked out how geckos can stick to walls and run up walls without falling off. And it's all to do with van der Waals forces. Now, I've put this on. It is not actually using van der Waals forces, but as it says here, it looks the same. So a bit of a film. So he is climbing up this glass using gloves, and this is what a gecko does, except in the film this is actually suction pads, but van der Waals forces would work the same way, so it's a bit of a cheek. So This is not to do with Van der Waals Forces. This is the film. I don't know if some of you have seen this film.
Yeah,
but he's climbing up the tallest building in the world.
Sandstorm.
There's lots of glass when it goes back to Tom
It's a long
Cruise
way off
climbing.
here. Shouldn't be a problem.
So it's the same sort of idea of Spider-Man as well in the films. So if you look at what he's doing with the gloves, we just go back to him.
You gotta be kidding me.
So look at how the gloves are working. We'll pretend that he's not using some sort of suction. One breaks there, right, we'll leave that now. So Tom Cruise's gloves wouldn't actually work. He's using suction, and one of the problems that we've got is that people are very, very heavy. Geckos are much, much, much lighter, obviously, but it's all to do with a surface area to mass ratio. Spiders use the same sort of thing, and spiders have it a lot easier because their body mass relative to the surface area is lighter again than geckos. Anyway, let's look at the geckos. So this picture here is a magnification of the underside of their feet. And you can see that as well as having this big surface area, they've got ridges on their feet. So A is a picture of the ridges on the feet. If you magnify those ridges are actually made up of closely grouped together hairs. And if you look at the end of these hairs and see as a magnification of the end of the hairs, those are, it looks almost like seaweed. So those have an enormous surface area. And D is a magnification of the end of the hairs. By the time you're magnifying again, if you look at D, if you magnified these ends, you're going to get to need an electron microscope, and we're getting down to molecular level. These are also bendy. So what happens is when the gecko puts its foot on a surface, these can bend so that all, as much as possible, is actually in touch with the surface. And this has got such an enormous surface area that Van der Waals forces come into play. And the gecko is actually sticking on with these Van der Waals forces that are just the movement of electrons. So the next step, once scientists worked out that that's what was going on, was to try and mimic it. And so this is where the Tom Cruise film comes in, just that idea. So we've got the gecko here. Spider-Man, we're just saying, well, imagine that he's using the same sort of force. And then this middle one, this is actually a TV presenter. He presented 3 programs. They pop up occasionally on BBC4. So if you see anything called Stuff Matters, then he presented 3 programs about material science. And this was actually using a material that mimics the gecko feet. And he is hanging on this is glass, so it's in a university lab, and he is holding on with his hands, but this is held onto the ceiling with Van der Waals forces. Now the person climbing up the window, it does look like he's on a ladder, but he's not actually. What he's got is pads on his knees and on his hands, and those again are mimicking gecko feet. Now there's actually a video of this, and he is going up incredibly slowly. I think he took about 5 or 10 minutes just to get up about 6 feet, about 2 meters. The problem, once you've got the gecko type feet, is they do hang on quite firmly. The gecko cannot just pull his feet off if he's running up a wall or a window, and the same with the chap climbing up the window. You've got to actually peel it off. So you lift up one bit of your hand, with the bottom bit, and you peel your hand off, and that makes it a bit slower as well. Now, just to finish up with, I've spoken about Van der Waals forces, and that is to do with this topic here. It also fits in with atomic structure, but it's mainly to do with bonding. So in the first year, this is just looking at the first year of the A level. We no longer do an AS, but there is an AS exam, and we do use it for practice at the end of the first year. And these are the topics in the AS, but also the first year of A level. So it's a 2-year course, and you do exams at the end of the second year when you will be examined on everything, although we do give lots of practice along the way. So the first year, the first term, it's atomic structure, amount of substance, which really covers maths and equations, things that quite often you will have done at GCSE, but we do a bit more thoroughly, a bit more detail. We have a lot more time to teach at A level. Bonding, where we've mentioned van der Waals forces, we're also looking at ionic and covalent bonding, again familiar from GCSE, and we start with organic chemistry. Then in the second term, we go on to looking at heat and energy transfer. We do kinetics, how fast reactions happen, equilibrium, reversible reactions. Particularly if you're doing triple science, a lot of this you will start off doing in year 11, and we just do them in more detail. Redox, reduction and oxidation, group 2, group 7, which I've mentioned with the halogens, iodine is part of that. Organic, and we do start doing things that you don't do in GCSE, where we're doing organic mechanisms, and we also look at alcohols in some detail. And then a lot of these topics, most of these topics, we carry on into the second year, quite often getting more mathematical. So energetics, kinetics, equilibrium, for example, we're looking a lot about the description. There is some maths in energetics, kinetics and equilibrium there isn't in the first year. The second year we carry on with these topics, but they get a lot more mathematical. There's also compulsory practicals. You have compulsory practicals or practicals you should do at GCSE, but you're not examined on them in the same way. They appear in the exams as part of the actual exams, but the practical part itself is not examined. Whereas in A level, there is a practical endorsement, and that is pass or fail. We do a lot of practicals. Obviously, it's very difficult at the moment in lockdown. We're trying to work out exactly what we'll do when we get back with doing practicals safely, but they're very much part of what we plan to do from September. And you get this pass or fail practical endorsement. Nothing to worry about. Everybody is expected to pass. And as well as the compulsory practicals, we do quite a few others as well. So it's a shame not being able to see you as we normally do, but I hope you've enjoyed the introduction to organic chemistry and all the other chemistries that we're looking at just here. And I hope to see lots of you in the next year or so at Woking College, looking at chemistry. So let me just stop sharing that, and it'll go back to the main screen. Or is it not going to go back? I'll switch the camera on. Better. So I hope to see lots of you in the future, and good luck in your GCSEs, and then A level the year after that. Okay, bye-bye.